Hello, it's James from xrobots.co.uk. This is the next part of my 3D printed R6 droid. Last time I put sounds in and various other things, and we printed some of these details. This time we're going to deal with some animatronics, so we're going to make all the flaps and things open. We've got a servo in the holoprojector that needs wiring in, and that's all going to be controlled from my crazy remote. But first of all, I'm going to print some detail parts to fill in some of the other things. We've got some other vents and things missing, and then we'll give it a drive around. The first part is the pocket vents, of which there are two on the front right hand side of the droid and the back left around the bottom. So these are funny looking things. I don't know what they were originally when they got them off a scrap pile or something. They've got kind of a bottom vent which is much deeper, and some short ones, and typically on an R2-D2 they are chrome or silver, and the orange piece would be blue, and this green piece I'm doing as a separate piece so it can be stuck on afterwards, but basically that would be the same colour as the main body. So in fact this piece is printed flat on the ground, the orange piece is printed flat on the ground, and so is the green piece, and then those are all stuck together to make the vent. Now I've made mine slightly wider than they should be, because obviously I've got no skins on my droid, but I still want it to cover up the part of the frame where that fits. And we can see there's sort of an overhang there on the blue part which will actually cover up the two frame verticals, and it shouldn't go that wide, and all of the slots should be thinner. But there we go, so it's slightly disproportionate, but it does fit perfectly into the droid. The next part is the octagon ports, of which again there are two, and I've seen various varieties of these. Some people have a kind of blue interior on their R2s and the rest is silver. So sometimes they're all completely silver, but I've decided to do mine in twin tone so that I can make my droid look a bit more interesting. And again, these are printed in two parts, one in orange and one in the silver ABS. So let's get those printed out and we'll see how well they fit. So the pocket vent fits in here. Ah yes, that's a good fit. And the octagon port goes in there. So we're just going to solvent weld that in with a bit of acetone, and then the other two go around the back. Right, that's enough music. Let's talk about the animatronics. So to control the servos, which are these ones, I've already bought a bunch of Hobby King single chip digital servos, and I've already used those for the utility arms and the holoprojector in the head, and I'll be using those for the rest of the features, mainly because they're white. So the boards I'm going to be using to drive these, so instead of driving these straight off the Arduino, which would need quite a lot of PWM pins, I'm going to use these Adafruit 16 channel PWM driver boards, which are I2C boards, and you can daisy chain as many as you like on the I2C bus up to about 62. And you'll notice they have these little solder link things, which is basically 6-bit binary, so you can have a binary number there bridged with solder counting up, and you can put 62 of these in a row, all on the same I2C 2 pins, and run 16 servos from each one. Here is the Adafruit tutorial page. Here you can see a picture of the board with a bunch of servos connected of different types, and a robot with some servos. The thing comes mostly assembled. You do need to solder on the pins there to attach the servos to, and there's some pins at each end to enable you to daisy chain them really easily, although you can just connect to 0 and 5 volts and then just go and connect the two I2C pins to each one. There's a terminal block on the front there which is power for the actual servos, which you shouldn't take off the 5-volt Arduino because the servos can draw quite a lot of current depending on what you're doing. So there's a hookup diagram here for various Arduinos. It is just power and two I2C pins. But those vary depending on your Arduino board, and of course you can chain these together, up to 62 together, and you can go in and out on the pins at each end, or you don't have to, you can just go and cable I2C to each one. Again, there it mentions how to address the boards, which I already mentioned, and that's basically gives you a different base address, so you specify that in code to say which board it is, and then you just set up a new PWM instance, and then you can address those individually. There is a library and some example code which drives a bunch of servos, which is fairly easy to use, as with most Adafruit products. And basically it tells you here helpfully how to use the map command to convert the pulse length into degrees, so you can get that servo to go to a precise position. So if you remember, my remote has got quite a lot of functionality. It's got this menu system for actions and sounds, which do various things on the menu, and also a bunch of buttons I can press, as well as the normal controls for driving and spinning the head. So the normal way to sort of code stuff in Arduino, or at least to say have the NeoPixels flashing in the logics, have various other things happening, is to sort of have some stuff happening. Then typically people do a delay of some amount of time, and then have some other stuff happening, and then have another delay with some other amount of time, and some other stuff happening, and then maybe some if statements. If a switch is pressed, do one thing, else do something else, and then we'd have a loop that takes us back to the beginning. The only challenge with this approach, when we've got so many things going on, so we've got all of the animatronics, we've got the sounds we need to play, we've got the logics flashing, which are NeoPixels, which are constantly counting up in a loop. The only issue we've got here is that these delays will actually completely stop processing, so the loop stops during that time. So that's not particularly great when we're trying to multitask so many things. So what we need to do is create something called a state machine. So using delays would mean if I wanted to open one of the utility arms and then close it a short time later, all the time it's delaying counting, I can't do anything else like play a sound or open another utility arm. So instead we're going to use a completely different approach using timers. Now within Arduino there's a variable called millis, which will count the number of milliseconds since the Arduino is booted, and if you use a long variable that won't overflow for about 56 days. And you can use that variable by bookmarking it, so making another variable equal to it, and then comparing that variable with the current time to see how much time has elapsed. So basically we've got a loop with the start of the loop, which is this red one, and the end of the loop, which goes back to the beginning, and then we're going to have a series of timers, which are these little clocks that I've drawn, and basically what we're going to do is change some states, and I've got flags here and I've called them flags in my code. So once an amount of time has elapsed, we can change the state from 1 to 2 or 0 to 1 or whatever it is we want to put in those variables. So I can, for instance, have an LED that flashes. It waits for an amount of time to elapse, sets its state to 1, which turns the LED on. All the time the loop is going round and around and around as quickly as possible with no delays. Eventually we go and compare the millis variable with the current time and see how much time has elapsed. And if a certain amount of time has elapsed, we can go and change that state to a 2 and turn the LED off again. And then of course the first timer would be basically an if statement saying if the state is 2 and the time has elapsed again, eventually it will turn that back to a 1 and make an LED turn on and off. So we can use this to flash LEDs, or we can use this to increment through various states. We could have multiple timers, or each time we could increment that value all the way up through all the NeoPixels in the chain, so that we can control the NeoPixels without any delay. All the time the loop is going round and round and round, so we can do other things at the same time. So, as well as having my NeoPixels flashing, I can have some more timers and some more variables with states in for the other features, like the utility arms. I've got actually 32 servos that I can control there, so we can have as many things in the loop as we like, because a loop is continuously going round and round and round, and it doesn't pause to do any of these things. It only does them when the timer says it's time to do so. So I can have another one, which when I trigger it, I can set a flag saying it's triggered, it opens the utility arm and it resets the clock and starts a timer specifically for that feature. I can then go and trigger another utility arm, and obviously all the loop is going round and round as quickly as possible still, so there's no problem with doing that. When the first timer expires, it can go and close that utility arm, and then when the second timer expires, it can close the second one. And in fact, we can have as many features like that as we want. So we can put lots of timers and lots of features, and we can trigger them at any time, and then we can have them run for a certain amount of time and then close or do something else, going to another state when that timer has expired. In fact, what I'm actually doing with these is giving them 3 states. So when they're not triggered, they're 0. When they're triggered, they're 1. And then I have an if statement saying if the flag is set to 1, I want you to open that utility arm, which sets it to 2, starts the timer, the loop keeps going round, and when the timer is expired, it then sets it back to 0. Obviously the utility arm is only open and closed, so I don't really need 3 states, but I've done that for a specific reason. The reason for that is that I've introduced another timer with another set of states, which is the cascade timer. And this one is yellow, so when that is triggered, it's triggered by a button on the remote, and that sets its flag to 1. But it also sets the first feature flag to 1. And when the loop comes round, it gets set to 2, and the timer starts. A bit later on, once this timer has expired, it then sets its flag to 2. And as well as doing so, it sets this flag to 1, which on the next loop round gets set to 2, and the timer starts. And when this timer expires again, it sets its state to 3. And it also sets this flag to 1, which then on the next loop round, when the if statement says if the flag's 1, open the feature, opens the feature, set the flag to 2, starts the timer, and at some point one of these timers is expired, so that gets set to 0, probably followed by this one and by this one. And when all of the states have expired, it could keep going up to as many as you like to activate or cascade as many of these features, each with a time delay in between. Then this one resets to 0 and everything starts again. And remember, the loop is always going round and round and round, so my NeoPixels keep flashing or my other features keep working, as well as my other trigger for sounds and anything else that I'm doing. So basically, I can set these flags to 1 at any time I want in anywhere in the code in the loop at any time, based on any combination of cascade or anything I want to activate. And I know that all of the timing related to that feature will be taken care of, and that the feature will open and close a short time later. So I could have multiple cascade timers, some which maybe open all of the flaps all over the thing, some which only open flaps in the head, some which only open the utility arms, and some which trigger others and in turn cascade the other features. All I have to really do is set a variable to 1 somewhere in the loop when it's triggered by something, which could be a switch, it could be another loop, it could be another cascade timer, or it could be something else built into the autonomous stuff which I'm planning for later. So here that is working. I've got everything that's going to be on the droid apart from the soundboards attached. So to demonstrate the code is multitasking, these 2 LEDs flash backwards and forwards all the time. My NeoPixels count round. These are flashing at something like 300 milliseconds each time, switching over. The NeoPixels are shooting round there at 100 milliseconds. So I've also got my 3 servos attached across the 2 boards. So they're addressed on each board. Now there is one weird thing I found with these servos. These are quite cheap servos. They cost about £2.50 each in money. They're single chip digital servos, and I found a strange thing, which is that I can't drive them to a new position with one command. So if I change the PWM value on the servo board in one go, they'll basically ignore it if it's too much. So if it's within right at the end range of their motion, so I'm trying to turn them 180 degrees. If I turn them a smaller amount, it works okay. and if I swap them for a normal analog cheap radio control car servo, that works fine as well. So the way I've got around this is by driving a value to these with a for loop which counts through every intermediate value. And this takes quite some time, and unfortunately it does hang the loop for a short amount of time. Now I could have made that increment be on a 0 timer throughout the whole loop as well, but I haven't done for now. And in fact the Arduino example code for these PWM drivers for actually driving servos actually already had this for loop in, which is the only way I actually would have found out how to make these servos work. So if you've got any other servos, then you can do true multitasking, but I've got a slight delay when the servos trigger. So for now I've got one button which activates this servo, and you can see the LEDs are still flashing, and a short time later turns it back. This one activates the second one, and the LEDs carry on, so there's no delay there. And if I press one, then the other, I can activate two of them at once. And all the time my code keeps running and my NeoPixels keep flashing. You'll notice the NeoPixels actually change colour as well. They go blue when I activate that servo, and red when I activate that servo. Then I've got the third button, which is the cascade timer, which operates all of them in turn, and basically just triggers those flags, and a short time later the timer expires and they all turn back. And I can do that in any combination, so I can activate this one, then I can cascade them. That one caught the end of the cascade, and I can just keep hitting buttons basically and activating those features. And of course the loop is still running, so then I can still have the commands for the sounds to play and anything else that I want to put in there. So I'm not going to go through the code in too much detail. There's also some really good examples in the Adafruit learning system for multitasking with Arduino, which is basically what I've based this on. So right at the top we've got all of the stuff here for setting up the NeoPixels, setting up the two PWM boards with the two different addresses to make our two PWM instances, defining the NeoPixels, and here we've got some definitions for open and closed positions from the servos. I've specified two different positions there, and done them twice. We could have obviously different positions for different servos, which are specified later on when we call them. So we've got RGB values there for the NeoPixels, and then we've got all our timers. So these previous milliseconds timers are the bookmark, so that's resetting the clock. And the ones here which actually have another name like pixel time or cascade time or LED time or on time, those are the actual times that the feature activates for. So pixel time is 100 milliseconds that the pixels count up each 100 milliseconds. LED time is in fact 500 milliseconds, which is how often those two LEDs switch over, and 300 milliseconds is how often those servos activate for. We've got various flags here which are set, which I mentioned, which is why I had little flags. And we've also got the triggers, which are basically reading the buttons. So at the very start here we set up the PWM stuff again, and we home all the servos, so these are across the boards, and these are actually calling functions that I've written. So I mentioned about scrolling through all the intermediate values, so these are the nasty for loops which hang the loop a little bit because they take a while to execute. As I said, if you have servos which work properly, you can just call PWM set PWM servo and a pulse length, and the servo should move there. In my case I'm counting through everything from the closed to the open position 1 unit at a time, and that's the only way I can make them work. So I've got two functions there, one for servo board 1 and one for servo board 2. The main loop is basically a bunch of if statements. So at the very beginning there we make sure our current milliseconds is equal to millis, which is a system variable, which is the variable I mentioned which counts milliseconds since the Arduino booted. And then literally all we're doing is saying, you know, if a flag is set and the time is expired, do some stuff in each case. So this is the one that switches over the LEDs. I've still got this rather unoptimized block of NeoPixel code, and I've also got the statements here to change the RGB values based on the flags for the servo positions, but typically one of the other flags down here, so this is the one that activates a servo. If the flag is 1, then it moves the servo, sets it to 2. If the flag is 2 and the time has expired, then move it back again and set the flag back to 0. And then we can just keep repeating that statement. We could optimize that again into a class or a function, but for now I've got one for each flag 1, 2 and 3, which are for the 3 servos, and I've also got flag 40. Bear in mind I've got 32 servos potentially, so I've started this flag well above the top value, and that's the cascade timer where it sets the flag to 1, activates flag 1, sets flag 40 to 2, then if flag 40 is 2 and the time has expired, then basically it goes and does something else. It sets flag 2, sets flag 40 to the next state. If flag 40 is in that state and the time has expired, then it sets flag 3 to 1, which activates the 3rd servo, and then sets its own flag back to 0, so everything's reset again. So the effect of that is activating those flags in order with a time delay in between, which is specified by the cascade time variable. All those parts are now fitted in the droid. I've got a servo board just in the head there, as well as the slip ring board, and the other servo board is just in the side of the droid above the coin slot, which you can probably just see there with an LED on. So let's give that a go. I've now got the buttons on the remote. So this one is a cascade timer, which opens the utility arms and a short time later closes them. And the bottom button activates the holoprojector. And the holoprojector's got 4 states, so it turns on the light, waits for a bit, moves the holoprojector, waits for a bit, moves it back, waits for a bit, and turns the light off. So that's a 4-state machine. And obviously I can activate the other features during that because it's multitasking, and I can still play the sounds. And I can still play multiple sounds and activate those features as well. And since there's a separate Arduino dealing with the driving and the head turning, all of those things still work as well, although I don't have enough hands. But ultimately I can drive this thing around and activate the features. So there we go. So looking pretty good. We've got a lot more features to add in. So we've got some more flaps on the head to put in, some other bits and pieces, as well as utility arms and lots of things which are all going to be built in the same way. Now we have that framework of state machine and timers, we can add all sorts of features, so the fun really begins. I still need to sort out that 232 conversion, which I think I'm going to have a go at next time, but apart from that we can add all sorts of other features like the periscope and all sorts of utility arms and flaps that open all over the droid, so it can really add some bling. So don't forget to subscribe to my channel for updates on this project and other projects, and also check out my social media links in the description to this video.